Alrighty, so in this video, we're going to make some changes to our function here for getting the instance socket transform. So you can see I've commented out basically what I've already done, because I want to go through and reiterate and show you the differences. So right now, here's what we are currently doing, and this leads us to some problems. The main problem is how we are actually kind of conjoining the two. So technically, we could multiply the transforms together in this and probably get it to work, but we're not going to be using relative transforms anyways. Well, we're not going to be returning a relative transform anyways. We're going to be using this strictly in world space, so it ultimately doesn't matter for us. So all we would end up needing is this code here, nothing more. So anyways, let me show you the problem. So right now, let me go ahead and place down a foundation. I have it set up so I can draw all the sockets so you can kind of see visually roughly what's going on. So you see everything's nice. It's positioned where it's supposed to be. Now I'm going to go and do it to the socket that actually works. So position 1. So I do that. And actually nothing is working because this, for some reason, the sockets are still showing here, even though they should be displayed over here. Now let me place it down at position 0. Now you see the sockets are over there. So we're having an issue here, and the issue is related to the origin point of the meshes and how we're actually handling them. So same deal. I place this guy. This one's correct, so that means I can just kind of keep extending it on that way. And oh, look at that. Here we have another problem. It's from over there when it should be on all 4 of these corners. Now the reason for that is how we're handling the rotation. Well, not necessarily the rotation, but how we're handling the transforms. So what we could technically do, and I actually attempted this first, is there is a function on our vectors here. Let me just make a vector real quick. That is still a commented area. So if we look at example, we have rotate angle axis. So what we could do here technically is pivot all the sockets on a specific axis. So that would be the instance's origin point that we were trying to put the sockets on. So we would pass in, the rotation of the instance in world space, as well as the axis, which would be the origin point in world space of that instance. And that, in theory, that should work. That should kind of take everything. Let me show you so I can help you visualize it. So that should be able to take all this. So the origin point for this mesh right here, I believe it is right there. I could be... No, I am wrong. No, I think it is right there. So basically what we would end up doing is we would end up rotating it around by, this would be 90 degrees. So it would take all of these. So for example, this top one right here where my cursor is, that would get swung all the way around to right here. And same thing for all these. This guy right here would get swung all the way around to right here. So in theory, that should work. However, there are simpler ways. So let me just Control Z and I'll show you the result first before we get into anything else. And here I'm actually drawing the origin point. So you see the blue circle, that's the origin. So if I place it down here, as you can see, we have the sockets are actually following. If I go over to here, the sockets are following. If I go here to fill up that corner, the sockets are following. And as you can see, it's working as it's supposed to. So the reason for that was how I was handling the transforms. I didn't actually put 2 and 2 together. So when I was doing the initial testing and we were using just the cubes and going vertically, that worked great. Perfect. We weren't doing any sort of rotation with the cube, and I never thought to even try it. So in my head, it just kind of, great, this works. So I went that way. Since we are having rotations on these, that's where we're having some problems. So that's where we end up, well, with this, because that is all that's needed. All this stuff is just for the debugging. That was all the circles and letters and stuff that you saw on the screen. You can ignore those, hence this comment. But that's really all we had to do. So I'm going to go ahead and clean up this function a bit and handle things that we do not need. So for example, we don't need the variable for world space anymore. We could set this up to work in relative space, but there's really no need. So we're going to go ahead and get rid of that. And we're not going to be using this inside a blueprint, so we really don't need to pass in a Boolean. So we can also get rid of that as well. So we just have the 3 parameters here. So we have our instance component, the index, and the socket name. So let's go ahead and go to the header and remove those 2 from the end as well. Just like so. Okay. Now let's go ahead and remove success equals true and success equals false down here, because we can also compare whether or not it was successful, like we are already doing right here, to dictate whether or not this is actually, empty. If it's an empty transform, then it failed. So it's not really a big deal for us. We're already doing that ourselves. So now that we have that, you can either leave the code commented out that was done there previously, or just comment it out, or delete it. Doesn't matter. But the main things that we want to check are, well, fairly simple. So I'm actually going to comment out this whole section as well, just for the debugging in case it is needed, and minimize that. And actually I can move that down here. Okay, so what we have, we want to make sure the instance component's valid. That's a given, just regardless. We want to make sure that it does contain a valid instance of what we were passing in. So that way, if it exists, then we can do something with it. If it doesn't, we're just going to return an empty transform. There's no point in doing anything because it's just not there. It doesn't matter. So that's just kind of safety protection there, even though it really shouldn't happen with our system, but it is possible. Anyways, as always, we want to go ahead and get the instance transform of the index we want to get, and we want this in world space. We also want to get the socket transform that we want to get. So for example, we need to fix this up here, but we're iterating through all the sockets that the mesh has. So we want to get that socket transform as well from the instance component, or in our case, for the showing of the example, the foundation mesh. And we want to get that in component space. Then we can bring that all into world space. So we're basically trying to think of a good way to explain it. So we take our mesh, let me go ahead and add that one. So here's our parent on the right side. We get our child here. So this is index 1. We want to get this in world space. So we know that origin point is right there. Well, we also want to get all of the socket transforms. Well, the socket transform that we're trying to get as well. And that's going to be in component space. So that's going to be a very small value. So for example, we have a socket that's actually right here at the origin point. That's going to be an f vector of 0, 0, 0. So 0 on the x, y, and z. There's not going to be anything else. Then we have this guy here, which is on the x-axis. So it's going to be 0 on the y, 0 on the z, but it's going to be whatever the distance from there to here is on the x. So what, like, I think these are 2 meters. So I think it's going to be like 200 centimeters. I think. 1, 2, yeah, that looks right. So that's what that value is going to return. Then what we can do is we can take that value and multiply it by the actual world space transform, and that gives us a place in space that is going to be corresponding to the child. So if we, for example, we have this guy here, which is on the y-axis, so it's 200y, 0x, and 0z. If we multiply that if we multiply our child instance here, so world transform, by the relative transform of this socket that's at 200y, that is going to put it right here. So it's going to put it right there in the child's leg here at the bottom. And that's what we want. So we know we are good to go there. And that allows us to go through, kind of place everything that we really need. We can go through, build out our foundation, set up our walls. Really just kind of however we like. We can place some right in kind of here. Place them here. You can just kind of alternate based on which one is closer. and you have yourself some rooms. Fun and simple. Oh, cool, we can't jump over that. Simple enough, isn't it? Alrighty, so that pretty much sums up the change that we had to make. I'll go ahead and if you haven't already copied this, I'll leave it here for a second while I talk. But that's all that you really need to do. Now the only thing we have to do left is where we call the function, we have to remove the remaining parameters, the last two parameters, the Boolean and the world space. And we can remove the is successful because it is no longer needed. And then one more thing that I want to do, which will end up probably being swapped out for other things because we're going to end up having to do checks to see whether or not a socket is in use. We're going to copy this where we get the foundation instance, like all the sockets for it. And we are going to move it into begin play, like so. And we want to store this in our header. So I'm going to go ahead and rename this one to foundation sockets. Go to the header, and under the meshes, we're going to do a T array and name it foundation sockets. Then we can come down and replace socket names with foundation sockets. Let's go ahead and close down the editor, recompile and relaunch. And once we're back in, let's see, what did I have open? No, right, that. Once we relaunch, go ahead and double check. Everything's working. So we know we are good to go. Just like so. Nice and simple. And one more, so we can place one there too. We really wanted to double up on walls. And it didn't quite mean to fall. But yeah. That pretty much sums it up. Now we can continue on, I guess, where we kind of left off. I don't remember where that was or what we're going to do next, though. So I'll have to go through the videos and see if I mentioned anything. Anyways, simple enough. We now have our building kind of set up, and it's going rather well. Better than I thought. We have to do things like fix the ability to do that. We don't have the ability to full-on, like, Minecraft this sucker. Unless you want to consider that a feature. But, plus side, we also want to remove the ability to do this, because we don't want to build a stack. But then we can just yeet ourselves out the map. Anyways, I'm just kind of procrastinating at this point because I'm very bored, but that's going to be all for this video. If you like what I'm doing and you want to help support me, you can find a link to my Patreon down in the description below, where I have a team deathmatch series just for Patrons, as well as you get early access to pretty much all of my videos, such as this one. If you have any questions or anything like that, feel free to join my Discord. That is also linked down below, and I'll try to help you out. So, I'll see you in the next one.